Welcome again. It's time to continue with our podcast series titled Science Will Make You Happy. I am Dan, Chief Science and Innovation Officer at Cybernetica, and joining me today we have Dr. Riivo Talviste, who is the product owner for Sharemind MPC and a security engineer at Cybernetica. So today we are talking about something that we have been working on together for a long time, I have to say. It's getting scary long. So secure multi-party computation, it's a set of words that confuses people. There is security, which is obvious. There is party, which is less obvious. And there's computation, which you usually have to explain what all of it is about. So I've always found that it's easier to explain MPC, which is an acronym for Secure Multi-Party Computation, by explaining what it enables. So what was the first cool MPC application that you ever made?
The first cool MPC application that I was personally involved with was actually, you can imagine like a secure service system where there are multiple parties who give their input data that is confidential, and then you get aggregate results, but not in an ordinary fashion where the host of this survey would actually learn the individual values, but in a way that only the interested parties learn the aggregated values, but nobody except original data owners see the input values. So there is no central database that could be like hacked or leaked or something like that.
So it was a survey. Who were you surveying?
So the practical application that was actually my master thesis was this kind of survey with MPC for Estonian Association of ICT Companies. And the problem was that, it's an association, a group of companies that are like-minded and that are working on the same domain or field. And they wanted to know how the economic sector in Estonia is doing in general. So we have these yearly official benchmark scores, but they wanted to do this quicker because ICT is a rapidly evolving field. So we set up for them this kind of service system that they could do bi-yearly or every quarter. So all of these companies, they just inserted some of the financial indicators, and then they collectively, all of them learned the statistical aggregates, like average scores and so on.
Okay, so multiple parties were the IT companies in Estonia. The secure part was that they did not want the other companies to learn what their financial indicators are.
And also the association as a
whole
legal entity itself, it also didn't learn anything about the individual values.
Because usually if you send out a survey, then there is somebody who sees the table of answers. And if it's an anonymous survey where you don't have to enter your name, technically we can still bind it back to you based on, for example, the network address where you came in to fill the survey from. So your computer leaves a trace. We can connect the survey result to a computer and maybe later to a person. So anonymous surveys are depends on how well do you want to know who answered.
They are usually kind of promised, saying that, we don't look at the data that we actually have that could identify you, I would say.
And so Secure MPC does better by making it impossible.
Yes, it's a technical mean, so it's a proactive mean.
Yes, and that kind of promises a lot. It promises a totally different kind of service. Because today if you go on a website or a cloud service, then the assumption pretty much always is that they know if you enter something, then they learn what this is. They have it in their database, which they can read. So MPC does things totally differently.
Exactly. So you basically remain in control. So because if you don't have that, then once you give out your data, if it's not like just one simple questionnaire with individual numbers, but if it's a larger amount of data, then you actually lose control. Because yes, you are asked for this data for a specific purpose, but so as the copy now is out there somewhere, held by somebody else, then you actually have no control about what they are doing with it. You only have like contractual promises.
Yeah, you have promises, yes. So that's how computers were built. Copying is supposed to be easy. Otherwise, we wouldn't have started to use them in the first place. Fair enough. Okay. So that and the technology right now, so that the audience knows, is still something that's an innovation. It's not there in most of the services. It's actually, it would be fair to say that it's very rare that you find a service that uses MPC.
Exactly. So at least the kind of like applications of MPC that deal with like large amounts of data are very rare. We only have pilots and very specific use cases, and you can find MPC in these kinds of like embedded solutions when there's like this very specific small like protocol piece it actually solves, but yeah, they are like purpose-built things, and unfortunately in many cases like one-off pilot projects. So you do something, you do some analysis or whatever you want to compute, and then it's done.
Yeah, it is the case indeed. So, but some of the promises of the technology have been quite compelling. We talked about financial reporting, financial surveys. There's a story that we've also worked on, which was the satellite collision prediction, which is very idealistic, but it sort of ticks the same boxes. Instead of companies, you now have countries
who own satellites, and we know that there have been like accidents in space where like satellites collide, and we want to prevent that. So how that would be done is that if we knew everybody else's satellite trajectories, we can predict if and how they are going to collide, and then one of them can do this kind of like evasive maneuvers to like change their trajectory. But the difficult part is that some of the satellites are not public, and their trajectories are not public data. So it becomes very difficult to actually do this kind of analysis. So this is one use case where secure multi-party computation can be helpful, because again we have those multiple parties with their own confidential input. So the countries, like you said, the satellite owners, and they do not want to share this data in plain text with each other, but they want to do this kind of like a specific previously agreed upon computation on it, namely pairwise compare or learn if the satellites are in danger of colliding. And the output can be just like one bit. So yes and no. If it's a yes, then you can like compute this needed evasive maneuver under MPC, or you can like return to the our current world and just do this under NDA, and that's it.
Tell the satellite owners that your satellites are in danger of colliding within the next week, so maybe you want to do something.
Exactly.
Many of them still don't have evasive maneuver capability either, but this is the future we're talking about. So we are living currently in an interesting time where collaboration of this sort between countries is it requires a certain trust and willingness. So I very easily understand why countries wouldn't want to do it in the normal way. Just, yes, here are all the coordinates, trajectories for all my satellites, including the spy satellites and the civilian stuff and so on. So show me where yours are and let's figure out which ones are going to crash. So MPC makes it easier. And this is where I think we come to the important part is why is MPC better than normal world or normal computation? You don't need to trust the other guys as hard anymore. We discussed that the companies don't need to trust their association. Here, the countries don't have to trust each other. It's a sort of a reduced need to trust each other is what we get.
Exactly. And one actually not so tiny thing that we haven't mentioned is that by definition, the multi-party computation, secure multi-party computation, it involves multiple parties. So yes, we have talked about the multiple input parties, but actually the name of the technology comes from multiple computing parties, which means that this is like not a single server or entity doing this computation anymore. So if you think about how this kind of data sharing economy works at the moment is that if two parties want to compute something on their data, confidential data, for example, and they don't trust each other, then they'll find this trusted third party and they just give both their data sets to this trusted third party who promises to do only those computations that they need and nothing else, and they also promise not to reveal the either of those data sets to either of those parties. So in a sense, we can think that this secure multi-party computation is technological replacement for this trusted third party, where we actually split this trusted third party among several physical servers or computing entities. And what we get there is the fact that there is no single party now that has all the data and that we have to trust unconditionally. We just have to trust the needed or necessary security assumptions. So I don't want to go into technical details here, but basically, in most cases, we just have to trust that those computing parties, like, for example, 3 of them or 5 of them, they do not collude.
To break privacy.
To break privacy, yes. Because if they were owned by a single entity, then of course they could learn the whole data. But the idea is exactly that none of them has the whole picture. And as long as they behave as they should, then everything is okay. And you just have to trust that they are motivated to behave, basically.
So this is quite an important thing. So there is willingness to collaborate, but you can still distrust each other. It's an interesting concept, and it's not so popular in the real world. As you said, as we discussed, there's various places where this has been very helpful. Okay, but let's dig just a little bit down into what those expectations can be. So I would assume that it's not okay if all these computing parties are controlled by a single organization. So this you mentioned. But how do we think about this? So if I have, for example, in this financial survey case, I had multiple companies. They were each hosting one computing system, and computing systems are talking to each other to complete the task. Can I run them on the same cloud? Should I run them on the same cloud, for example?
That's a very good and practical question nowadays. So the answer is that it depends. And it, as always, boils down to risk management. In theory, from this academic purity side, I would say no, because there exists a single entity, namely the cloud provider, who, by definition, actually has access into all of their virtual machines. We know that they probably don't have time to look at all of their virtual machines, but still there is this kind of entity. However, in many practical use cases, that might be possible. So I can't really answer that without a specific use case, and it's actually not my decision. It's always the decision of the asset owner. So they can do this kind of risk analysis. But this is something to definitely talk about. Luckily, we have plenty of public cloud providers.
Yes, you can pick separate ones
with compatible APIs. So that's technically not a problem in many cases.
One thing we should also make clear is we mentioned these input parties. They're the ones filling in the surveys, and they're the ones who send in the satellite data. Can there be arbitrary amount of them? Can there be any number of them, or should they all be also computing parties? How does that work?
So it's a very how do I say? Difficult world. So there are very, very many different kinds of secure multi-party computation scenarios or so what we are mainly what my work is mainly concentrating on is the type of MPC for outsourcing data analysis, and there we can actually distinguish three types of roles, like you said, input parties. Then we have mentioned computing parties, and then there are output parties or result parties who get for example, in the case of this financial benchmarking survey, they get these aggregated values, and the technical protocol tells you how many computing parties you have. For example, 2, 3, 5, 7, and then they come with these security requirements. For example, if some of them can collude, some up to some threshold, or what's the technical guarantees. And in most cases, the number of input parties and output parties is not limited. So and this is what I mean by outsourcing. So you set up the system, you pick the computing parties, and then you can have basically any number of input parties to come with their data and compute on it and give the result to authorized output parties.
If I translate that to be a bit simpler, then if I'm the end user of an MPC system, to me it looks like a normal system. I just know that somewhere in the background there is a different set of servers who are working together, yet slightly against each other, or not against each other, but together, but not fully together, to make sure that I retain the privacy of my data.
Exactly. So there are variants of MPC where all input parties have to also be the computing parties. For example, in the garbled circuits case, but in the computation outsourcing case, that's indeed it's indeed how you said. So the input party, the ordinary user, for example, with their financial data, again coming back to this use case, is they don't have to actually even know that the system uses MPC in the backend, and that has actually proven to be difficult, because for the end user, it looks like a normal web form that they fill in, and unless they go and look at the source, for example, the JavaScript of this web page, they have no idea that whether it goes to a single server, like in plain text as usual, or it's actually distributed among the computing parties. So
it's up to the service provider to decide that I am making a service where my data providers, my data donors might not fully trust me. So if I want to get them to believe me, I will give them additional controls. I will give them a system based on MPC or some similar technology, so that they know that I cannot abuse their data or misuse their data. Now, today systems are built that do various things with your data, and not all of them use MPC. there's also other technologies. So what are the main differences of those? There is in cryptography land, there is homomorphic encryption or fully homomorphic encryption, does similar things to MPC, but with a single server, let's say. And then there's confidential computing or trusted execution or whatever have you. So how do these things position against each other? So what's the advantages of each if you need to pick?
I would say that they are just different. So yes, they can be used for similar use cases. If we talk about fully homomorphic encryption, then that should be the obvious choice. I always tell students when I talk about different secure computing technologies that this is the holy grail of secure computing, because, well, why should I pick or deploy multiple servers in secure multi-party computation when I can do the same thing with a single server?
Yes,
because this doesn't
sounds
break.
Compelling.
Yeah, this doesn't break the usual client-server
paradigm,
protocol or paradigm. Yes, exactly. But the thing here with fully homomorphic encryption is that for this generalized computation, if you just want to program anything and let it compute anything, then it's terribly slow still. Many orders of magnitude slower than computing on plain text, and at least couple of orders of magnitude slower than computing by secure multi-party computation. That doesn't mean that it's not practical. It's very practical in some solutions. For example, for some very optimized sub-protocols, even to, I don't know, bootstrap some MPC protocols or vice versa. So they work in tandem very well. But again, we come to specific use cases and so on. So FHE is deployed in practical use cases, but if we talk about data analysis and this kind of general computing, then it's not yet suitable for that.
It's a bit of as if MPC several years ago. So initially, you could do basic statistics with MPC, and then it got better and better and better, and then we managed to be the first team in the world who implemented this satellite collision prediction on MPC, floating point numbers and cool algebra and continuous math and all the things we did for that. And FHE has also been developing and trying to catch up with all these capabilities. It's getting better. So maybe if the audience listens to this in a few years from now, then you may have a different reality. But today, this is all correct. There's FHE has a single server setting, which looks really good, but you can't make it do all the possible computations efficiently. Whereas, yes, MPC has had some more time to optimize itself. But what about hardware? Hardware security. This is increasingly more used, but again, we don't see many services advertise themselves that I am using trusted execution environments to protect your personal data. So why isn't it an obvious winner?
I actually can't answer that, because I would like just every service to be deployed that way. I think in many cases, unfortunately, the answer is that maybe the general population just doesn't care enough, so that the service providers would actually need to redesign their services. But technologically speaking, it's also a very, very good alternative to MPC, because we again have a single server. So in trusted execution environments, you have a single server, like an ordinary CPU. It just has the capability to create protected processes, and protected processes mean that the memory the process has is encrypted, and other processes working in parallel on the same host machine, they can't actually see into this protected process. And usually everything that this process writes to the disk is also encrypted on the fly. So they are like really, really segregated from the rest of the operating system, although they are working on an ordinary host machine. And you can pretty much do anything with those processes. And in this case, it's a very good candidate. It's just that we can't really see into those processor architectures, because we have process manufacturers who do not necessarily want to show us how their processors are built, so we have to trust the vendors. Whereas secure multi-body computation is a software-only solution, so you have a lot of open source implementations, you have proprietary implementations also, but even there you can in many cases look at the, for example, source code under NDA or something, but you don't have to go to the on the level of how your processor is built and understand it, because I think there are very few people in the world who actually could reason about the security of processor architectures.
Yes, for viewers who would want to know more about that, then I refer you back to a previous episode that I recorded with Armin, which goes deep into the detail of trusted execution. But here, so the problem here is that it comes down to trust again.
Exactly.
It comes down to trust. With MPC, the trust is distributed, it's decentralized. That's how I've understood. That's one of the reasons why MPC has been popular in the blockchain Web3 world, because this world is inherently very decentralized. And the problem is that with trusted execution, you have certain, let's say, roots of trust which are very hard to control for individual organizations. You can't control how Intel or ARM or anyone else is making their CPUs. They give you some promises, but those are controlled, they're limited promises. So yeah, with fully cryptographic solutions, you can say that my thing will be secure on any hardware made by anyone. In a way,
exactly, and it's a very good point that you made with this Web3, is that yes, in both cases there is trust needed, but for example, this Web3, it is really interested in this no single point of trust or distributed trust. So that's a big point here.
All right, I think we've given an explanation, so people hopefully understood the financial survey and they understood the satellites example. So now we can. This is a mandatory part of explaining people MPC. You had to explain what the point is. So we've been doing it for a while now.
Indeed.
Yes, it's the Sharemind MPC system that Cybernetica makes will be 20 years old next year. That's quite the thing. So let's look back a little bit before we start looking forward. So what do you think we have done well? Why have we been? Why are people using what we do? Why has Sharemind MPC stood the test of time in a way? So because if you ask chatbot today, if you ask ChatGPT or some LLM and you ask about MPC implementations, then Sharemind does come up. So we've won this part. So what is it that you think we've done well over the years?
Yeah, indeed. Sharemind MPC pops up if you talk about, for example, commercial offerings of MPC implementations. And I think the secret behind that is trying to solve actual practical problems from the beginning. So yes, indeed, the first publication about Sharemind MPC was in 2007.
Yeah.
Your master thesis?
Yes.
Yes. So I assume that the first lines of code were written in 2006 already, but
I've tried to find that repository, but I've actually started looking for it because we may have to have a party next year, and I've tried to find some of the historical first artifacts, I have a file which says that I did something in 2006, but I don't yet know exactly when. I need to take some boxes from the basement and see what's in them.
And I joined the project in 2009, and already by then the question was not necessarily how can we make those protocols faster, which is the obvious research question, but it was rather how can a client from a remote machine access the computing nodes? What's the protocol? How is the data distributed? All these kinds of things. How to write applications on top of that? So do we want that only the small team that actually has built this implementation, only then they can create all of the applications on it? Or do we actually invest into documentation and developer resources and build a platform? So that's what we have been actually doing. So in 2009, I joined, and I was actually tasked with getting web-based client working. So making the input data secret shared in JavaScript, which was not as easy then as it is now.
Yeah, technology. Well, you can do so many things in web applications today. This is amazing what you can do now. Many of the things weren't possible back then. But yeah, that's. I would agree that we focused on the applications early on, and people knew that. They knew that maybe our research papers weren't the most complex or didn't have the coolest cryptography and the fanciest math, but I think we always had compelling use cases and stories, so the things that we want to implement with this. So that's true. I agree. There's and we've gone past that. I'm glad we agreed on that the end user has been sort of in the center. We tried to make the end user happy to use this complex cryptographic world that's somewhere in the back end there. But so that's just me being nostalgic, I guess. Times have changed, but this is a technology that hasn't necessarily been adopted super quickly. So I know companies who started working on MPC after Cybernetica started doing it. They raised money, were venture funded, and promised big breakthroughs in data privacy and cybersecurity and so on. And some of those companies are not here anymore. So they ran through their runways and aren't there. So it's a technology where getting it right has been tricky for many people, even those who have had a lot of resources. So but we have moved forward. So you've been going to conferences and developer meetups and speaking about the technology around the world. So what's something that's people are still working on this? What are they working on today? So what's the frontier for this technology?
Yeah. When I was, for example, in my PhD studies some years ago by now, then the big thing in all of those conferences was, for example, speeding up garbled circuits tenfold and hundredfold and so on. So it was like protocol level optimizations. Past couple of years, I think at least in the academic circles, what has popped up out for me is a thing called function secret sharing, which is a different concept of secret sharing, and secret sharing is the basis that we do secure multi-party computation on. So a lot of let's say development teams or research teams are talking about the function secret sharing. And this actually brings us to this nice shift in development and optimization, is that until now, most of the MPC protocols have been network bound. So, we just get the best network that we can for a deployment, and we have to live with it. And the local computation is usually like a small portion of the overall time. With function security sharing, the amount of local computation actually becomes important. And now we have discovered, or like the research community has discovered, that hey, we should start looking into speeding up computations with GPUs, for example. So that's a new avenue that I've been seeing explored in research conferences. And the whole point why function security sharing is researched so heavily is mainly machine learning. Also like inference, and in some cases training also on MPC.
Well, everything. We live in a moment where AI and ML are really popular, so that's an obvious use case for all of that. So there is still development ongoing, and this now brings me a bit to a big piece of work that you have recently done. We completed a project for Eurostat, which is the European Statistics Office. And this project was titled JOCONDE, spelled slightly differently than the famous painting, but joined... can you do the acronym for me, or can we neither of us do it right there? Joint computation with no data. Yes. Anyway,
I don't know.
Yeah, that's a shame. It's really a shame. But we'll move on. The point was that we sort of combined the two first use cases we discussed. We discussed surveys and statistics, and then satellite collision prediction. So from the first, we want to do statistics, and from the second, we take that we want to do it across borders between multiple countries. And so it's you've been working on this for 2 years now. You've been doing risk analysis, prototypes, benchmarks, anything. So what was the goal of this project? What new capability would we get from MPC?
So the goal of this project actually is very simple. So we just want MPC to be deployed for official statistics. So in one sentence, that's the goal. And a little bit of background is that actually official statistics is full of innovation. So concepts like privacy enhancing technology, secure computation, and MPC in particular are not unknown to them. So there has been several like data analysis or statistics like pilots involving secure multi-party computation technology. But the problem is that it's a pilot. So it's a one-off thing, and then nothing usually happens. And I guess I don't have to like talk why actually we would even need secure multi-party computation in official statistics, but just to give you some quick pointers is that official statistics is no longer something that a single statistics office does in their country. So there's a lot of cross-border collaboration between, for example, the member states in European Union and also globally. Secondly, we have a lot of very interesting data sets that are privately owned. And of course, these owners do not want to share those data sets openly with even with statistical offices. So these are all very good use cases for MPC. But now coming back to this like specific project, and what it's solving is that if you just do these like statistics projects, one pilot after another, then it's really time consuming and expensive because for each one of them, you have to deploy the MPC, you have to maybe program it, you have to gather all of the parties, explain what's the technology all about, and so on. So it can be like a multi-year project each. So the idea of this JOCONDE platform or solution actually is to build kind of this MPC-as-a-service solution for official statistics. So you have a single deployment of the solution, and then the clients of the system, which are the input parties and output parties. So the ones having the data and the ones interested in the aggregate results, namely statistical authorities, they can come together as clients, form these kinds of consortiums or project teams, and they can just very quickly pick these like computation nodes or computing parties, a suitable set of them, and just agree what input data they need, how it's used, what is computed, then everything is agreed upon, and then this kind of task is sent to the solution, and statistical authorities get the end results. So what we take away is that we don't have this very time-consuming and costly deployment, so we can reuse the same system over and over again. I think that's the main point of this idea.
Meanwhile, I remembered it's joint computation with no data exchange.
Yes, exchange was the...
My memory
yes, exactly.
started working, yes. Right, so this is... so now we're taking all of the experience from building MPC systems, like individual pilots, individual things, and we're trying to make it into a big repeatable platform. So what are the, if you would have to bring out some things, main innovations that you had to build over the last 2 years to make sure that this goal is actually reached?
Yeah, it was not an easy task, I have to say. So we tried to take everything we have learned from the past almost 20 years, and we have had a lot of different deployments for different use cases, and bring everything together in this solution. So first of all, this as a service sounds very nice, and this is something that you would get from a cloud provider. But this technology, multi-party computation with distributed trust and as a service usually do not mesh really well together. So we had to work really hard to provide this self-service experience without introducing a single point of trust. Because like our project manager on the Eurostat side put it, so if we introduced accidentally, for example, a single point of trust, then it will be just like a glorified service system. So just piling different technologies, but not actually be any better. So that was one of the goals. And security-wise, we combined different technologies. So we combined secure multi-party computation with trusted execution environments. So although they can be seen as competing technologies, you can also put them together so they would actually enrich each other. So we are very heavily in this design taking advantage of the remote attestation capability of trusted execution environments. And then the actual MPC protocol is executed inside the trusted execution, which gives it some very nice extra guarantees, just like on top of the purely cryptographic guarantees. And then to do this self-service process easier, we came up with this concept of computation task and and came up with a way how everybody could agree what are the inputs, what are the computations, and once everything was agreed upon, then what the input parties and output parties actually do is they all digitally sign this task, which basically contains all of the technical information that is ever needed to execute it, and then this task kind of starts to live its own life on the solution. So after this, nobody can change anything anymore. So you just upload the data, you know that it goes to the right place, nobody can access the plain text data, and the input parties can be absolutely sure that only the computation that they have actually signed is the thing that is executed, and their data is not abused.
This looks like a dream platform for people who read an MPC textbook and then think that how would this need to look like if it was a big and industrialized system. So I'm quite sure that there have been multiple attempts at building something like this. So here, for me, I haven't been I was attached to the part of the project where we built the trust building mechanism. So, because whenever you promise that you will build a big data processing system that will calculate something based on information from many people, then instantly some people might think that you're building a big surveillance system and you will be analyzing people's behavior and whatnot. So, me and a colleague, we worked together on the trust building plan, explaining why this is not the case and how you can, as an institution building this service, make sure that this perception is not the winning one. And that means you have to take the technology which gives you properties that normal IT systems just don't have. So this whole end-to-end security and all. And then you have to build on top of it and make it really clear to everybody that this is exactly that. And this attestation part helps really well. And even then there are pieces you can't do with technology. You still have to educate people. So, but at least, let's say, I'm quite sure that based on the work you've done and all the regulatory and work with the legal documents and all, then if they exist, then the influencers in this space will also look at it and find it quite impressive what we've done. So I'm very happy about all of this, at least. And
I'd like to point out that while this solution is built for official statistics, the same architecture works in very many different scenarios.
Mm-hmm.
But I'm actually really thankful for Eurostat for bringing
strong vision, I would say.
Yeah, for this vision, because it really helps to try this solution out in a very specific scenario, like
Mm-hmm.
official statistics that has its own regulations on the legal side and own process that we actually had to adhere to. So it makes designing this system very kind of like practical and easier, and then we can take it from there to other domains if necessary. Because I think that if we were to start to like come up with a very general MPC-as-a-service for anyone's kind of system, then we couldn't really have agreed upon any scope to begin with.
Without a business case, it's hard. Over those 20 years, we've tried taking your survey system and building it into a general thing. Like imagine, like, I don't know, what do people use? SurveyMonkey, Google Forms, whatever.
Lime Survey.
Lime Survey, whatever is your favorite tool of choice, and then build an MPC version of it. And we did it. Then we looked at the financial side of it and the business case and saw that it's not a very strong business case, really. But for official statistics, things that countries, governments, central banks depend on to make their policy decisions. Here it's a compelling case, and it's not as, to be a bit blunt, it's not as defense connotated as satellite collision prediction, because there it gets into politics very quickly. But with statistics, it's all kinds of organizations, European Union specifically, all kinds of things that you want to calculate across member states, which are possibly somewhat sensitive. This is now a capability. It doesn't have to be the European Union. You can think of United Nations, OECD, a lot of the other multinational, cross-national organizations.
Exactly.
And they could use all of that as well, and for analytical tasks. But then there's, as you said, there's other applications. So the same financial surveys doable, health becomes a use case. So it's really quite an interesting point. Cybersecurity, I know a few companies in MPC space who have tried to use MPC for doing cybersecurity threat intelligence collaborations. So you, instead of showing other people your data and calculating statistics, you can use your threat intelligence and compare it to other people and to see if you're being attacked with the same attack, for example, and if it's the same attacker, or do joint attribution of your attacker find where the command and control nodes are for some networking.
Exactly, and in some cases it's just as simple as comparing the list of IP addresses, which you don't want to do normally, but if you put them together from many different, for example, victims, then you might find something very interesting.
Anti-money laundering.
Exactly.
The IP addresses was a great thing. We worked with, some years ago, with some European banks building a system that would easily help you compare lists of account numbers, IBANs, to know that if several people see that this account is in my suspect list, then they would be able to more easily do bulk processing. Because obviously it's always a bit easier if you suspect someone, if you have an investigation going on, and try to then find someone else who is suspecting the same person. So I think this account is suspicious. How would you know about this? Are you seeing any of it? But that's just like that doesn't give you efficiency. What we know from law enforcement and, for example, tax or these use cases is that you need to do this in bulk, because you don't know who is trying to cheat you or who is trying to fraud you or anything like that. So technologies like MPC and other security computing technologies are actually quite good for finding the needle in the haystack, finding the suspects. And the current legal basis in law enforcement don't always give you the right to look at everybody's data. But I remember another project we did, one for the Estonian Tax and Customs Board and one for the UK Cabinet Office, which both were looking at data from companies and individuals and trying to find fraudulent behavior in them. So the point was exactly that you take all the data and you then say, what's your definition of potential fraud? And then you get the candidates. And the calculation has to be agreed to, much like you described for JOCONDE, in a way that everybody knows, okay, if this says yes, then there is a reasonable doubt that something bad is happening. So, and once you get this out, you can start the investigations. But yes, legally, quite a bit of a challenge in JOCONDE, in this Eurostat project, was also to understand what does it mean, because there has been a lot of disagreement in the technology space on whether cryptographic secure computing makes data anonymous or not. So I think we've settled that question for some time now, yes?
Our take is that it's still processing. You still have to have a legal basis for the processing, and you can just show that you are like going a above and beyond the state of the art that is required in the regulations to protect, for example, privacy of end users or like other types of confidential data. So I think that's the take care. So you can't really say that this law doesn't apply to me because I'm using secure computation. So that's not going to fly, I guess.
Yes, and this is, but it's a very reasonable attempt now to still use it, because you can show that you've been doing things better. And one of the interesting pieces of European regulation in data protection is that they often work through the state of the art. And if we can show that because of the threats in cybersecurity and have become so much more serious, then all our defensive measures, supplementary or primary measures, have to become more serious. So technologies like MPC will hopefully be state of the art as years go on. And I personally feel that this Eurostat project makes this future come closer, because if this is now, there's a lot of open source, there's an open source implementation. It will be much easier for institutions to pick it up and start applying it. So hopefully MPC will be state of the art, and then it will be something people will have to use a lot more, because we see how just again during the recording of this, recently Apple has come out with their new operating system version with a great big review apologies, on how they do secure AI. And it also is starting to use increasingly more secure computing, combinations of cryptography and trusted execution. So it's coming. Now the question is, private sector is doing it, the big technology platforms are doing it. So I guess it's now time for industry and the public sector to follow suit. So,
yeah, exactly. You can nowadays find MPC deployed in some everyday applications. It's very specific there. Unfortunately, there are no this kind of big general computation things, and I think computing statistics and machine learning is with JOCONDE is a step in the right direction in that regard.
So I think one of the final things to talk about is, so if you are now one of these AI coding enthusiasts, then how easy would it be for you to take your tool of choice and then decide that you're going to build an MPC system and use that? So can it be done? Is it simple? Is it hard? What do you think?
I think nowadays it's pretty easy to implement MPC, so that's not a question. The protocols are all available because research is open. It's public. The same applies for our protocols. But the difficult part is actually deploying it, and of course, if you want to deploy it with real data, then you have to do the legal analysis and everything. So the use case specifics, business case, legal analysis, technical deployment, these are actually the difficult parts. So this is where we find that our experience maybe is very very good and very valuable, because it was the case that you needed a big development team and a lot of resources to actually implement MPC. Now I guess you can just do it alone with your AI agent and basically do it in a week. So that's not a problem.
So which part of MPC's Sharemind MPC is really hard to re-implement with an AI agent today? If you think about what part, what's the unique secret sauce that we have still that won't be replaced with an AI clone very quickly. I have an idea in my head, but I don't know. I wonder what you think.
From the top of my head, if we talk about just implementation, then I think most everything can be done. At least if you build for a specific solution. If you want to build a development platform like we have opted to do, then you want to do this like optimizers, and there is this like uncertainty that is actually the application code that someone else maybe writes on your platform. So this is somewhat difficult. I wouldn't say it's impossible, but yeah, it's like building development platform for so that somebody else can also use it is always difficult than just solving one solution.
Yes, that's what I exactly had in mind. I would think that the protocol optimization system that we have, that's a pretty neat piece of technology that would likely be harder to clone. So that gives a lot of the efficiency and also some automated security proofs. And so what's for the future? How can we, what do you think will make Sharemind MPC a trustworthy solution to somebody who's going on the market and is making the decision that, okay, will I try to implement my own? Will I take one open source thing, or will I try to go with Sharemind MPC? So why should I decide that Sharemind MPC is better? So is there certification for MPC systems?
There is actually no certification. No, not even common criteria. All the common criteria is really like applied a lot in all kinds of different cryptographic implementations, but currently there is nothing specific for MPC. So I think that the certification is, for example, our track record, if I may say so. And the decision whether to implement something oneself or use something, for example, commercial or open source, is whether this person wants the maintenance burden. And that's honestly the biggest thing. So we have decided that we take on some maintenance burden for everybody else, and keep a very fresh and very performant set of protocols available for everybody, along with development tools necessary to use that. And I think from in the current setting, that's kind of the best we can do, because we don't know all of the problems that are out there that need to be solved. So we just want to be ready to solve all of the problems, but it doesn't mean that we ourselves are the ones actually implementing these solutions, but we would like to offer maybe know-how and tools to solve these problems.
So exactly, that's a great way to conclude. If you feel that this dream of being able to compute on things and solve problems for multiple organizations, multiple parties, whether organizations, countries, or whoever, and doing it in a privacy or confidentiality preserving way, then yes, Sharemind MPC is here for you. You can use it in whatever field of life you need. Thank you very much, Riivo. And until next time, when science will make you happy again.